I'm thrilled to introduce Richard Wollack for our first talk, Antarctica, Continent of Extremes. Dick worked 10 years with the U.S. Antarctic Program with significant assignments at all of the American stations aboard the research vessel Hero and in the dry valleys. He wintered as leader of the U.S. Amundsen-Scott South Pole Station during the transition from the subsurface IGY station to the geodesic dome. Dick's material contributions to the U.S. program were honored by the naming of Wolak Peak in the Trans-Antarctic Mountains. His graduate thesis at MIT explored the effects of extreme polar isolation on group dynamics and mission accomplishment. He currently teaches an Antarctic-based course at the University of Connecticut. Now, I'd like to turn it over to Dick. Thank you for joining us today.
Thank you, thank you. Thank you, Arlene. Thank you for inviting me, for the Seaport for putting on this great day. Antarctic junkies will be, very gratified to be able to go through this day of these lectures. When Arlene first called me, just kind of to do some full disclosure, when Arlene first called me, she hadn't really settled on the full agenda, and so we didn't really talk about what my topic would be this morning. We said, well, we'll put that off. We'll discuss it later. So in the meantime, I thought I would get a head start, find out how these observances perhaps were done in the past, and maybe I could, borrow something from some previous programs. So I started into my research, and it started off very well. I found this program from the Nathaniel Palmer House, just up the road from here. Locals will know where it is. And it was a 25-year-old program, 1995-96. And I said, surely I can find something here. And I did. I opened it up, and there it was, November 17th, celebrating the 175th anniversary of. But I then quickly said, well, maybe this won't be so much help to me, because this particular talk was one that I did. So I said, well, okay, that's fine. I will assure those who were there, I'm sure there's many of you out there who attended, that this will be a much different talk, in that back then we didn't even have PowerPoint, so it was mostly just slides. So anyway, topic today, Antarctica, Continent of Extremes. I'll be kind of flying through this material because I have a lot to cover, and when we get to the end, we may have some opportunity for questions in any case. So what I'd like to do today is go over origin and characteristics of the continent, a little bit about the exploration. We'll kind of fly through that. IGY in the science era. I don't know how many of you know what IGY was. It's a few years back, but we'll, of course, discuss that. A little fun at the end, maybe 5 minutes to talk about what I call the Stonington Cemetery connection. We're here in Stonington. Stonington is a big part of what we're talking about today. So this is just a little bit of fun of something I discovered. And then Q&A when we're done. So quickly into the size of the Antarctic continent. The Antarctic continent is the 5th largest of the 7 continents, makes up about 10% of the Earth's landmass, and is a bit over 1.5 times the size of the continental US. You can see here the 48 contiguous states, about 3.5 million square miles. The Antarctic continent generally considered to be about 5.5 million square miles. So this is a magnificent view of the Antarctic. This has actually been put together from satellite photos. It's been patched together, so this is the continent itself. And this view points out one of the most amazing things about it, and that is the continent is 99% plus or minus covered by snow and ice. You have the Trans-Antarctic Mountains and the Antarctic Peninsula where there's a bit of exposed rock, this being kind of the extension of the South American Andes. But for the most part, it's entirely covered with snow and ice. If you want some, of the volume, we're talking about an average thickness of about 7,000 feet, something approaching 1.5 miles. In volume, something on the order of 7.5 million cubic miles. If you can imagine a cubic mile, it's a little difficult, square mile, a mile high. 7.5 million cubic miles of ice representing probably about 90% of all the ice on the planet and more than 70% of all its fresh water. More than 70% of all the fresh water on the planet. Now, it's the coldest of the continents. I think a lot of people already know that, not a big surprise. It's also the highest of all the continents, more than double the height of Asia. It's the driest of all the continents, a virtual polar desert. It's the windiest of all the continents. And we'll talk about each of these a little bit. It's cold primarily because of the Antarctic circumpolar continent. When the land bridge between South America and the Antarctic Peninsula opened, it allowed this massive current of cold water to run around the continent and to cause the continent to become ever colder. Now, this circumpolar current, the largest ocean current on Earth, the flow is estimated as something around 130 sphere drops. Now, I'm going to guess that a lot of you aren't familiar with the term sphere drop, but I can tell you it's a measure of flow that is equal to 1 million cubic meters of water per second. 1 million cubic meters of water per second. And to give you some idea of how much water that is, it's estimated that the freshwater flow of all the rivers on Earth, flowing into all the oceans on Earth, make up about maybe 1.1 sphere drops. So you can imagine how big a current this is and what effect it has had on the continent. It's high. Here you see an elevation map. It shows that some of it over 4,000 meters, ice as thick as nearly 3 miles. I told you already that the average thickness about 1.5 miles, and this constitutes an elevation that is more than double the average elevation of Asia. Dry. Equivalent annual rainfall in Hartford, about 44 inches. We're all pretty familiar with that. Phoenix, an area that we consider to be sort of dry, about 8 inches. Parts of the Sahara Desert, 3 to 4 inches. At the South Pole, equivalent annual rainfall, maybe 1 to 2 inches. And that, of course, is not in form of rainfall. That's, maybe 4 to 6 inches of a very dry, crystalline kind of snowfall. And then windy. Windy because of what are referred to as catabatic winds. Catabatic winds are gravity-driven winds. We all know that cold air is heavier than warm. So you have air masses that are cooled over the center of this massive ice sheet, or the Antarctic ice sheet, and then flow down toward the ocean based on gravity flow. So that winds at the Antarctic coast of 100 miles per hour are not particularly unusual. They've been recorded as high as 200 miles per hour. There was an Australian explorer who was there in the early 1900s who once recorded, I think, a full day, a 24-hour day where the winds had been greater than 90 miles per hour, and then a full month where the average wind was over 63 miles per hour. Now, not all of the continent is that windy, but there are areas that are. Where did it come from? Those of you who know about tectonic plate movement, continental drift, seafloor spreading, whatever you want to call it, know that there was once a great southern continent called Gondwana, or referred to as Gondwana. It was made up of what are now the southern continents plus the subcontinent of India. And that, in fact, was the origin of Antarctica, which eventually, through this tectonic plate movement, went down to the southern spin axis of the Earth. Here, another chart showing some of the animal forms and plant forms that shared these various continents, kind of more of the proof that this, in fact, was the origin of the Antarctic continent. In the South Shetland Islands, the area that Palmer went to, you can still see evidence of this. This is petrified wood found on one of the islands in the South Shetlands. Here, this Glossopteris fern fossil, typical of the common ferns, making it all very obvious that at one time Antarctica was, in fact, a tropical continent. And then this is fairly new stuff. What lies beneath the ice? They're learning that beneath the ice, kind of at the place where thermal warming from below and then cold ice from above meet a balance, in fact, there are a series of lakes and rivers, actual flowing, water-flowing rivers that exist below this massive ice cap. Now, just a quick comment about nomenclature. You perhaps have heard sometimes what's called East Antarctica or West Antarctica. East Antarctica considered greater Antarctica, West Antarctica lesser. And what's fun about it, of course, is if you're approaching the continent on a southward, typically the US program approaches from New Zealand, so they're going due south. And of course, if you're on this course and you turn to the east, that in fact aims you towards West Antarctica and vice versa. Well, the answer to all this, of course, is based on the longitudes that we're talking about. Here, the zero meridian of longitude, which goes up, of course, through Greenwich, England. If you go east from Greenwich, you're, of course, in the eastern hemisphere. And that, in fact, is what defines the fact that East Antarctica is in the eastern hemisphere, West Antarctica in the western hemisphere, as we are. Okay, quick summary of what exists on the continent. Plants, no. Animals, no. Native peoples, certainly no. Tiny exceptions to the first two. There's always exceptions. So plants, vascular plants, upper order plants, there are two. There's this grass called the Schampsia antarctica. There's this pearlwort. I'm not exactly sure what a pearlwort is, but this is called Colebanthus sketensis. These two plants exist in the Antarctic, but even they go no further south than about 2 degrees within the Antarctic Circle. Antarctic Circle at about 66.5 degrees south. So these will maybe be as far south as 68.5 degrees south. Quite a difference from the Arctic, where you have tens of thousands of people that live within the Arctic Circle and flowering plants that go perhaps as far north as 84 degrees north. More common further north are some lichens where you can find exposed rock and mosses that, of course, are not what we would call upper order plants or plants that share nutrients within themselves. Going to the animal life on the continent. Now remember, I'm saying on the continent, terrestrial animal life. Essentially none, certainly no vertebrates. There are some microscopic worms called nematodes that exist at places. There's a small wingless fly called the Antarctic midge, which again lives perhaps in the mosses or in those plants that we mentioned. But again, that's it. No upper forms, no mammals, nothing of that sort. And so you say, well, what is there then? Well, a lot of ice, which we've already discussed a bit. This shows you the continent ringed by this massive area of sea ice, frozen ocean. In what is probably the greatest seasonal change that takes place anywhere on Earth, the continent at 7.5 million square miles basically doubles in size because each year about 7 million square miles of sea ice, frozen sea, gathers around the continent and then goes away. It's an annual thing, pretty amazing. So here's the sea ice, or the so-called pack ice. Some aerial photos. You can see there's various leads, it moves, it changes. Here you can see some younger ice, again, some of these fissures or leads. But it's an amazing part of the Antarctic area. And drawing here from my functional glossary of ice terminology, and book that I'm sure most of you have, or many of you have, the significant parts of the sea ice, it reflects solar energy, what's called albedo. You can imagine the difference between solar energy when it's hitting this white ice as opposed to when it's hitting the darkish sea water. So big difference between different parts of the year. It inhibits the exchange of water vapor, obviously adding to the dryness of the area. it changes the salinity of surface water. And I won't really go into that, but when seawater freezes, it leaches out salt. Obviously, when the seawater then thaws, it's more fresh water. So you get these vertical currents that are set up based on the changing salinity of the surface water. And then it also supports the food web, and I'll talk about that a little bit further on. So here's sea ice of McMurdo Sound. You can see, I include the picture so you can see some of what's called the pressure ridges and the various parts of the ice that change. Group of Weddell seals here in front, and we'll talk more about them later. Sea ice from an icebreaker that I was aboard. Sea ice being broken by the very same icebreaker you can see turning up these blocks of frozen seawater. And then we go on from frozen seawater to frozen freshwater, or glacial ice. The icebergs of Antarctica, of course, are bergs that have broken off from glaciers that are flowing to the sea, all different sizes and shapes, some amazing stuff, and pretty incredible when you consider that what you see here above the surface actually represents something like this, because you maybe have, depending on the density, 10 to 12% visible above the water, the other 85 to 90% below the water. And then we have the real behemoths of the icebergs, and that is the tabular icebergs. The tabular icebergs have been calved off of the great ice shelves. There's 3 pretty large ice shelves in the Antarctic, and then some smaller ones as well. These things can be enormous. Now, we'll look at this animation. They are, of course, disappearing. We know that. So here is ice shelf retreat and collapse on the Antarctic Peninsula since 1989. You had the Prince Gustav ice shelf, it's gone, the Larsen A ice shelf, the Larsen B ice shelf, and then most recently, about 3 years ago, this large iceberg that broke off what is called the Larsen C ice shelf. So that was dubbed A68. There's a nomenclature system for these large bergs. That was called A68. And the significant thing about it was that not only was it very large, something like 2,200 square miles, 2,200, about half the size of Connecticut. It represented 1/8 of the Larsen C ice shelf. So there's concern about the potential collapse of that ice shelf. Now, it's been in the news. We now have a large berg. It's A68A. That's an indication that A68 has broken a bit. There's, in fact, also a A68B and C, much smaller than A. But it, in fact, since July 2017, when it calved, has been moving north, and here, A68 position this month. And the concern is, if you read any of this on the news, is that it is going to impinge, or appears like it's going to impinge, on the island of South Georgia. Here's aerial photos, A68 down here, South Georgia up here. Now, it won't run into the island per se. I mean, obviously, it's not a very deep iceberg, but there is a fair bit. So it will go up near to the island of South Georgia, but then because it will probably last for many years before it either moves again or breaks up, it's probably going to cause quite a bit of problem with the wildlife, the seals and penguins and birds that make South Georgia such an incredible ecosystem. Now, just to give you some perspective, this is B15, which calved off the front of the Ross Ice Shelf. The Ross Ice Shelf about the size of France. But that was in 2000. B15 was about 180 miles long and about 25 miles wide. Its area was about 4,500 or 4,200 square miles, essentially twice the size of A68. This is pretty near the size of Connecticut. Maybe, 3 times the size of Rhode Island. So pretty interesting stuff. Animals in the Antarctic. And I said earlier, no animals on the continent. We all know, of course, there's animals in the Antarctic. There's birds, there's penguins, also birds, seals, all marine supported. The wildlife in the Antarctic are marine wildlife forms, and their big thing is adaptation. This is a Weddell seal, the most southerly of all mammals. It's able to dive to something like 600 meters and stay down for an hour. You know, and while we don't have the time to really go into the characteristics, you have ice fishes without any hemoglobin in their blood. You have the penguins. Now, penguins, of course, there's, I think, something like 18 different species. The only two that are genuinely Antarctic penguins are the emperors, the largest, and the adelies. Here are the emperors. Talk about adaptation. They breed in the winter of Antarctica. So they're pretty amazing. And the adelies, I'm going to start moving along here a bit because I can see that time is moving. Crab-eater seals, 6 different kinds of seals in the Antarctic. These are what they call crab-eaters. The fur seals, obviously we know about them. That's what Nathaniel Palmer and his group of ships were going to find. Leopard seals, elephant seals, and the Antarctic krill, shrimp-like being that is 1 to 2, maybe 1 to 3 inches long. And this is the basis of the Antarctic food web. The krill are enormous quantities of krill. They, of course, graze on algae, bacteria, and protozoa, which form on the underside of the sea ice, giving you some idea of the importance, again, of the sea ice. So you have the krill that have grazed on these smaller forms of zooplankton, and virtually they support every other form of life, larger form of life in the Antarctic, with the possible exception of the orca. And of course, the orca are living off everything that's living off the krill. Okay, a little bit of history. James Cook, the great Antarctic, or the great world explorer, in 1773, 3 times crossed the Antarctic Circle, first man to do it. He never saw the continent, never was close enough because of that sea ice, never was close enough to see the continent. He saw a lot of ice. This was done by his shipboard artist. But he concluded that if there was a continent down there, there would be no reason anybody would want to go there, and that probably nobody would ever get any further south than he had. Well, of course, that wasn't true. Here was the hero coming out of Stonington in 1820, 47-foot sloop accompanying 4 other vessels from Connecticut, going down there because they understood there were a lot of fur seals there. Yep, there he is, our hero. Portrait done of him probably when he was about 40. Remember when he was on the Hero? He left Stonington at age 20, turned 21 before he got to the Antarctic, but an amazing individual, he and 4 others on the Hero. And then, of course, the U.S. 25-cent stamp that honored his trip. You can see here in white his trip down to the Antarctic Peninsula. They, of course, as I showed you earlier, a fur seal, another one here, that was their goal. Now, just a quick aside, the Hero name lived on in 1968. This is the research vessel Hero. I had the pleasure of working with Hero for 4 years when I was in the Antarctic Program. Launched in 1968 in South Bristol, Maine, 125-foot wooden vessel, both sail and diesel powered. Okay, 1820, some of you may know this. Palmer, of course, did see land here around the Antarctic Peninsula, as did a British captain on the Williams, Bransfield, as did a Russian captain on the Vostok up here, Bellingshausen. And Bellingshausen we're going to talk a little bit more about later. Here's his stamp, actually an Estonian stamp because he was born in Estonia. But the interesting thing about him, and I think you'll hear more about this from Glenn, who will be following me, the encounter between the 2 great Imperial Russian ships, the Vostok and the Mirny, and Palmer on his 47-foot sloop. And he, of course, had an encounter with Bellingshausen, Fabian Bellingshausen, that's in the history books. Okay, what happened after that? Well, about 20 years later, you started getting exploration done from sea. This is the Vincennes, part of the USXX, which was the U.S. exploring expedition, 1838-41. Charles Wilkes of the U.S. Navy. Now, he did 2 trips to the Antarctic. This one, where he didn't really accomplish very much, but the second out of Australia, where he did a great deal of surveying along the Antarctic coast, and it was a very significant trip. Charles Wilkes and his 25-cent U.S. stamp, and then the James Clark Ross expedition, British expedition, 39 to 43, Erebus and Terror. And I include this one because it was a very significant expedition, and it included the Terror, which is reputedly the ship, the bomb ship, that stood off of Stonington and bombed Stonington during the War of 1812. This was an incident where the 2 ships nearly ran into a large iceberg and then, in fact, ran into each other, causing some damage. Okay, not a lot happened over the next 40 to 50 years, but then we started what is called the heroic age of Antarctic exploration, when man was really coming onto the continent and doing more than just sailing coastwise and doing marine surveying. This ship was the Belgica, the first to winter over below the Antarctic Circle, inadvertently 1899. They were caught in the ice for about 14 months here along the coast. We don't have time to get into the story. It had some pretty interesting people aboard. Roald Amundsen, who we learn about later, Frederick Cook, the American physician, Henryk Arctowski, the Polish scientist. 2 of the 3, the first and third, both have Antarctic stations named after them at this point in time. So, and then of course the attempts to get to the South Pole itself. First attempted by Captain Scott, the British Captain Scott, on his discovery expedition of 0103, followed by the Nimrod expedition of Ernest Shackleton, 0709. While Scott had only gotten to the edge of the Ross Ice Shelf, Shackleton had gotten to 88.5 degrees, what he considered to be within 100 nautical miles of the pole itself. Yeah, Shackleton and his group, they had worked out how to get up the massive Beardmore Glacier that got them from down at more like sea level up to the high Antarctic plateau that is pretty much featureless. They worked out of huts like this that were in the Mcmurdo Sound area. And I include this only to show you that this picture that I took probably 80 years after this equipment and this particular hut had been built shows you the effect of the very cold, dry atmosphere in the Antarctic. That what we think of as rot or decay just virtually happens very, very little. Here you have some seal carcasses, again, nearly 80 years old, which are still kind of there from the cold, dry atmosphere. And then finally, the end of the South Pole story, the Norwegian Amundsen in 1911 coming out of a place called the Bay of Whales. Captain Scott back on his Terra Nova expedition, arriving about 5 weeks later in early 1912. Here are the Norwegians looking at the tent that they had put up there while the British were still heading toward the pole with their ponies. Not a good idea. Amundsen had done it primarily with dogs, which was the way to go. Worse idea, once the ponies were gone, the British were man-hauling. They got there in January of 1912, saw the same tent with the Norwegian flag on it, took a final picture before they headed back, and of course, to those of you who know the story, they never did get back. All 5 died on the 800-mile trip back to McMurdo Sound, ending up with this cross, which is now overlooks McMurdo Sound on a small volcanic cone near McMurdo Station. Quickly also, some of you know the name Ernest Shackleton. He came back. He said, okay, now that someone's been to the pole, I'm going to cross the entire continent. I'm going to start here, go there. That didn't work out. His ship, the Endurance, of course, got caught in the ice, eventually got crushed. They were moving their lifeboats over the sea ice, eventually got to an island called Elephant Island, and did this unbelievable 800-mile trip in this small boat, this 21-foot boat, to South Georgia, the island I mentioned earlier. Just an amazing adventure. So, We're now at 1920, 100 years after Palmer and these other sea captains, and really not much has been seen. The continent, the black part here, has not been seen or explored. Most of the peninsula has been seen. You've had the two people that went to the poles, so they've seen the Ross Ice Shelf. But that's pretty much it. The next 30 years, not a lot was going on. Most of us know the name Richard Byrd. He had set up his Little America stations. He had done some flying in this Ford trimotor. Lincoln Ellsworth, another American with the Polar Star, had done a trans-Antarctic flight. These two planes, if you want to see them, this one's in the Ford Museum in Detroit. This one at the Air and Space Museum, Smithsonian, the Polar Star. But that was going on. Countries were beginning to claim. 7 different countries claimed pie-shaped wedges of the Antarctic. 3 of them overlapped here, the United Kingdom, Argentina, and Chile. The U.S. has not made a claim, nor did Russia. Both of them said, though, that they did not necessarily recognize the claim of anybody else. Then came what I alluded to in my first slide there, IGY. IGY was the International Geophysical Year. It was an 18-month period from the 1st of July, 1957, until the end of 1958. And this really started up the scientific era. During IGY, there were 40 stations set up by 12 different nations. The U.S. had 7. You see the 7 red dots there. Palmer Station was not one of them. Palmer Station came later. But the U.S. did have 7 stations set up during IGY, and it included man's return to the South Pole. Not on foot, not with dogs, not with ponies, but in this R4D, this military version of the DC-3 called the K-Sera, which landed at the pole on Halloween Day, 1956. You can see over above was a larger C-124 Globemaster, because this was kind of a gutsy thing to do. They didn't really know. Nobody had been there since 1912. They had no real idea of what the surface was like and whether or not they'd be able to take off from it. You know, what the landing would be like, what the takeoff would be like. So these guys were around to kind of drop them supplies should they need it. By January 57, a station had been built, a U.S. station had been built at the South Pole, a place where I had the pleasure of spending 13 months myself, though not in 1957. I was a bit too young for that. The result of IGY was that the 12 nations that had participated in IGY wanted to continue. So in 1961, they put together the Antarctic Treaty, probably one of the most successful international treaties ever. Very quickly, it applies south to 60 degrees, territorial claims set aside. That was significant. Open access for science, shared programs and data, protection of the flora and fauna, no military, no nuclear, and ongoing meetings to kind of update and upgrade. Now the Antarctic Treaty, I think, is signed by something like 53 or 54 nations, representing well over 75% of the world's population. Here's the stamp at the 10th anniversary of the Antarctic Treaty, 61 to 71. When I joined the program a little over 48 years ago, it was the United States Antarctic Research Program. You're going to hear more about this afternoon, since a current member of the program is going to be speaking as part of this program. It morphed a bit since then into what's called the United States Antarctic Program, a little bit different in the logo. And its permanent, and I won't go much into the program, but its permanent assets right now, Mcmurdo Station, South Pole Station, Palmer Station, and then the forward operating base for ship assets out of Punta Arenas, Chile, on the Strait of Magellan. There's also a very interesting area about 70 to 80 miles from Mcmurdo Station called the Mcmurdo Dry Valleys. This is an area that NASA has great interest in, has done a great deal of research. They consider this area, and we don't have time to go into why they're dry or what they're about, but they consider this area to be probably the area on Earth that is most like what we expect to find on Mars. So they've done a great deal. It's an extreme desert. It's kind of at one end of the cold, dry spectrum for life forms. Just an incredible area. Again, I had the pleasure of working there one summer with a Russian geomorphologist. This was our two-man camp that we would live out of for a little bit and then move on. So the scientific goals of the US program: understand Antarctica, obviously. Understand how it interacts with other global processes in other parts of the world, meteorology, oceanography, and then to use its unique features and its unique location to do science that can best be done there. Astrophysics is an example. And again, not a lot of time to talk about. Now, the US program has been something of a dominant program because of our ability to use the LC-130 Hercules. This is the Hercules aircraft capable of extending skis, hydraulically extending skis, so that they can land either on wheels or skis, depending on the nature of the surface. And then, of course, the marine assets that we'll hear more about: the Lawrence Gould, the ice-breaking research vessel Nathaniel Palmer. So quickly now, going back to this slide, you remember that in 1820 there were 3 different ship's captains that sighted the continent. And I thought when I was going to do a talk about one of them, I was going to do a talk about Bellingshausen. And I wondered if there was some connection that I could find. I mean, remember 1820, it wasn't a very global time. We consider now that the world has been globalized, so that there's a lot of connection between what's going on, but not necessarily back in the 1800s. And so I was curious, is there some connection I could find that even existed back in the 1800s? And I call that connection the Stonington Cemetery connection. Now, those of us who are local know that that's where Nathaniel Palmer is buried. This is his headstone there. Another picture of the same headstone. And what I found was that about 50 yards away, there was a small obelisk that was of great interest to me. Here it is again, a little bit closer. And I said, well, this is a person. It wasn't George Washington, but it was a person whose first and middle name was George Washington. And I said, well, that certainly, merits a US flag sticker. Here he was an engineer. He was born in 1800, about 9 months after Palmer, so they were contemporaries. He was similar to Palmer in that Palmer at this point in his life, this is about 1837, I think, when he came to, this man came to Stonington. He was an engineer who was doing cutting-edge railroad and locomotive design and construction. Palmer, of course, at this point in his life was doing the same with sea transportation, with clipper ships, and this is something that Glenn will be talking more about later on. So this man went to England in middle of, well, getting toward the middle of the 1800s to learn about railroad design and construction. He, like Palmer, was highly successful in his projects. And he came to Connecticut, he came to Stonington during the development of the Providence-Stonington Railroad. Here he was, he and his family took up a place. Here's the borough, most of us know what that is, the Stonington Borough. So he was living in the middle of the Stonington Borough in 1837. He and Palmer, both at that point about 36 or 37 years old. Here, by the way, is where that cemetery is, where they're both buried. And in 1842, 5 years after he'd taken up residence in Stonington, Tsar Nicholas I called from Russia. There was hardly any railroad in Russia. They wanted to build a railroad from St. Petersburg to Moscow. He called on this engineer to help develop the St. Petersburg-Moscow Railway. There's the northern part here, southern part here. They did some amazing work with these incredible railroad truss bridges. One in the Soviet Union now, the current rebuild of this bridge, still referred to as the American Bridge. In 1847, 5 years after he got there, awarded the Order of St. Anne of the Second Degree by Tsar Nicholas. Well, here's where the plot thickens a bit. This is a map that kind of shows you the perimeter of St. Petersburg. And in the harbor at St. Petersburg, there's an island called Kronstadt. And Kronstadt, as you can tell from reading this patch here, Russia Baltic Fleet, Baltijski Flot, is the traditional home of the Russian Baltic Fleet. Well, who should show up there in this period of time but our friend Fabian Bellingshausen, now Admiral Fabian Bellingshausen, the military governor of Kronstadt from 1837 to 1852. Well, amazingly enough, who else shows up at Kronstadt but our friend the engineer? He designed the arsenal, fortifications, and docks, or was involved 1842 to 49. So here was the man that Palmer had interacted with in the Antarctic, now clearly interacting with this engineer, this railroad engineer from Stonington. Well, 1847, an outbreak of cholera in Russia, dealing, I guess, with something like we're dealing with now. I think something like 1 million Russians were lost during that particular outbreak of cholera. So the engineer's wife and family left Russia. They were with him, but they went to London to take up temporary residence. The engineer contracted the disease in 1848 and died in St. Petersburg in 1849, which would appear essentially to be the end of the story. But there is a little bit more, as they say. It was a pity. His young son, who apparently showed some ability in art, had started studying at the Imperial Institute of Art in Russia. And of course, he had to leave that. But later in his life, he continued his artistic endeavors. Here, a painting he'd done called The Thames in Ice, or if you're from this area, The Thames in Ice. Obviously, he and his mother were living in England at the time. Here's Sunset Red and Gold, The Gondolier. The Princess from the Land of Porcelain. So those of you who are art buffs know what I'm talking about here, that this engineer was in fact not Whistler's mother, but Whistler's father. Here's George W. Whistler, George Washington Whistler, father of James McNeill Whistler. Okay, so we've made it through to what will be the Q&A portion. I've actually gotten this done reasonable time. I'm sure the first question would be, where can I learn more, or where can I be entertained more with this whole story? And the answer to that is the radio dramatization south of Cape Horn. This is jointly sponsored by the Granite Theater in Westerly and the Stonington Historical Society. It's in fact a radio dramatization first aired in, I think, 1949 with Mickey Rooney playing the part of Nathaniel Palmer. It's on tonight, 7 o'clock this evening. It's a Zoom presentation of the Granite Theater. You can go either to stoningtonhistory.org or thegranitetheater.com. You'll be able to find the link. It is a ticketed presentation, but you get to choose what you pay for the ticket. It's obviously a fundraiser for both these organizations. And so when you go to Eventbrite to get your ticket, you get to put on the price on the ticket, whatever you'd like, and that will give you a Zoom link to hear this dramatization of Palmer in the Antarctic, discovering the continent, as I say, this evening at 7 o'clock. All right. Anyone here has questions or?
Thank you, Dick. We can take questions now from our live and virtual audiences. So if you're online, feel free to use the chat function to send through the questions. And I'm here to take any questions from our in-person audience members.
This is a question from Brian in the audience. How is the Adelie population doing? Hoping I'm saying that correct.
Yeah, it's the Adelie penguins he's asking about. How are they doing? It's difficult to tell. Around Palmer Station itself, they've been doing studies on the Adelies on a small island near Palmer since back in the 70s. And that particular colony has pretty much been decimated. They seem to have moved further south. The Adelies, as I said earlier, are a genuine Antarctic penguin. They spend their entire life in the Antarctic. And because of the warming trends and the smaller quantity of sea ice, they seem to be moving further south. The numbers around Palmer are not very encouraging because, as I say, the studies that have been done there, and you can find these online or in books, there's been a lot of difficulty. And the fact that the warmer atmosphere causes more rain, what exists in the peninsula is not good for penguin chicks, for chicks that do not have their adult feathers, who have just kind of a fluff. So they're having difficulties. Exactly how the numbers are doing, I'm not really certain. They appear to be down in some areas, but we don't know if perhaps those areas have been displaced to places a bit further south. Yes. Oh.
The question is the ice on the main continent disappearing along with the ice shelf?
It is. I have with me a short video that was done by NASA, by Jet Propulsion Lab, which is part of NASA, where they're concerned with what's called Lesser Antarctica. You remember I showed the West Antarctica, that there's not far from the peninsula are several glaciers that the so-called grounding line, the place where they leave the continent, has been moving back. And that means because these glaciers have been flowing more quickly to sea, and there definitely is a concern with collapse of those glaciers. It is said that Greater Antarctica has not appeared, the bigger part, the East Antarctica, has not appeared to lose much ice over the last, say, decade, but even there, the thought is that that is starting to happen as well. It's obviously a very slow process. It's interesting to note that if all that ice were to go off and melt and go into the sea, it would raise sea level by something in the order of 190 or 200 feet. So it's serious stuff, but obviously you're not going to see something like that happening for quite some time. But the answer to your question is yes. The terrestrial ice is in fact also lessening, as is the sea ice.
Okay, so is G.W. Whistler buried in St. Petersburg or Stonington? That's a question from John in the audience.
Yeah, no, John, that small obelisk that was on my slides is where he was buried. The family home at the time was Stonington. So when his wife and son came back from England briefly, they buried him in the Stonington Cemetery, I say about 50 yards from Nathaniel Palmer. They then went to live with some family relatives in Pomfret, Connecticut. But in fact, George Washington Whistler did end up being buried, as I say, about 50 yards from Palmer in the local cemetery.
Another question from the online audience. This is from Guinevere. How many people are at McMurdo Station?
McMurdo. McMurdo is the largest of all the Antarctic stations by quite some bit. Antarctic stations, of course, typically have a lot more people during the Antarctic summer than during the winter. So summer population at McMurdo can go as high as 1,200 people. They, of course, are also working over in the valleys. They're working in field camps. But that's the center of the U.S. operation where all of the aircraft that fly inland to the South Pole are based. So summer population can go, certainly not this year, of course, but summer population has been going up to perhaps 1,200. The winter, probably about 150 to 160. My son spent the winter of 2010 there. I think they had about 160 people basically doing some data collection and then maintaining the assets of the program for the large influx of people during the summer. Summer in Mcmurdo is probably beginning of October till mid-March, and it's probably the middle of that period when you have the largest population.
All right, do you have time for a few more
Sure.
questions?
Oh, yeah.
Yeah,
Right.
there's actually a lot coming in from
Yeah.
the online audience.
We have all the time.
This is from Isabel. Can you talk about how many expeditions there have been to Antarctica?
How many? Wow. Scientific expeditions, of course, I showed you the early ones in the mid-80s, mid-1800s, where there weren't so many. The so-called heroic era of exploration, I think there was probably about 12 different at the time. Then, of course, between the 20s and the 50s, there was probably a half dozen or 10. But since then, of course, there's been a great number. I mean, the U.S., there are several national programs. I told you that now signatories to the treaty, there's 50 some odd. So you have the Chinese, the Indians, just Koreans, many countries, many South American countries, all of which have stations in the Antarctic, and of course are doing expeditions. So, there is a book out there that attempts to, done by a British historian, quite a large volume, that attempts to cover all of the various expeditions. It's about a $200 book. But all I can say is there's been a great deal, certainly since International Geophysical Year, when the science era really began.
The question from Thomas, what was Palmer's career after his exploration?
I will not get into that very much because
Glenn,
Glenn, who's going to be following me at 12:30, that's his topic. Incredible man, incredibly successful, like our engineer, incredibly successful with design and operation of clipper ships. And I'll leave it at that because you can get a lot more in better detail, I'm sure, from Glenn Gordon here.
All right. Victoria is wondering, I like this question, any advice for someone who would like to visit Antarctica?
The tourist ships, which of course are pretty much expedition ships, pretty much on hold this year, will resume, I expect, next summer, the summer of 21-22. I think last year there was something like 56,000 people that visited on the expedition ships. These are tourists. That is a pricey way to go. They're not inexpensive, probably the least expensive, certainly on the order of $6,000 to $8,000 per person, and probably up from that. For a person who has a skill needed in the program, the way to get there is to apply for a job with the Antarctic contractor. The U.S. program has a logistics support contractor, and to go online, find out who that is, and apply for a job. And remember, they have a lot of semi-skilled or relatively unskilled work. People who work in the kitchens and the dining, well, I shouldn't say kitchen, but the dining rooms and maintenance people. So depending on someone's skill set, there's the opportunity to get on and get a paid job at a place like Mcmurdo Station or Palmer Station. And it's work, it's real work, but certainly a great opportunity to get down there.
Looks like we have one more question, I think, from the audience. This is from Joe. Richard, are you hopeful that the Antarctic Treaty will be renewed, unaltered, or when it's up next for review, and when will that be?
Next review, I believe, when it was originally signed, they talked about doing a review, I think, in about 30 years. Many people wrongly thought that that was the end of the treaty, but it wasn't. It was simply a review. And, it had been so successful that, of course, it continued. They added some elements to it. Now, as I say, you have so many countries that have signed on. I believe the next review is in the 2050 time frame, and that I'm not sure of. I'm sure this is all available online if you wanted to look at the Antarctic Treaty system. But it's certainly hopeful that it's going to go on. I mean, the big question becomes, will there be such an interest in whatever minerals or whatever assets are there, geologic assets, that people will want to scrap the treaty in favor of exploiting, either the sea life or the mineral of the continent. But it's done well so far, and my hope is, or my expectation is, that it will continue on past its next review.
All right, we'll let this be our last question from the online audience. This is from Roberta. When was Antarctica actually formed, and how long did the formation take?
The map I showed you of Gondwana, I think, was labeled 400 million years ago. The land bridge between South America, this is the Andes Mountains, that then, extended to the Antarctic Peninsula. I believe that opening occurred about 30 million years ago. And that, as I said, about the circumpolar current, that would have been the beginning, 30 million years ago, when the cold circumpolar current started causing the whole continent to become more and more cold. So you go back to Gondwana maybe 400 million years ago, the opening of the land bridge with South America probably about 30 million years ago, and it was in that last 30 million years that it became the continent that it is now.
Thank you. Are there any other questions from our in-person audience? The question is, this gentleman has heard that there's pollution problems due to all the people down there. Is that correct?
I think what you're probably referring to, I think it was Greenpeace back in the 80s or 90s, early 1990s. We're concerned about that, set up their own summer station down there, and started pointing out that some of these stations were really getting rid of a lot of solid waste just on land or in the ocean. That caused a great cleanup to take place virtually at every station on the continent, because the scientists, who of course were the primary part of these stations, realized that yes, we're not doing the best job. We're using stuff, but then we're just discarding it. So you had a period, the person asked about getting to the Antarctic. There was a period, if you were willing to volunteer to go down there to help clean up some of these stations, I think Greenpeace was sponsoring groups that went down there to do that. Now in the US program, everything is like hiking in the national parks. Essentially anything that goes in comes out. And this includes all kinds of solid waste, that's generated at the US stations. Our hope, our expectation is that the other nations are doing the same. Certainly the ships, all of these expedition ships, these tour ships that operate, I know from having worked on many of them, they dispense with nothing when they're south of 60 degrees. When they're south of 60 degrees, south latitude, there's very special rules for their operation. They do not use heavy fuels for fear of losing fuel. Nothing goes overboard while they're in the Antarctic area. So at the beginning of your question, yes, there was some element of that going on. There are still groups, I'm sure, that are concerned with that, but there's been a big change in that over the last 30 years.
Great, thank you so much for sharing your experiences and knowledge with us today, Dick. And thank you to all the participants who joined us.